in a minute or two. We're just kind of waiting for a few more people to join. So we're just having a casual conversation. Feel free to jump in if you wanted to. So anyway, go ahead, Matt or Mike.
Oh yeah, I was just gonna say, Microsoft Flight Simulator. They released it. This thing is beautiful. 100 gigabytes.
Oh wow!
You got to download it, right? And I was at the store the other day. I was looking for some cables, and I see this guy. He's looking at these computers, like $1,700 desktop computers, and he's talking to the sales rep, and he goes, "Yeah, I just want to play Microsoft Flight Simulator." As I drop I'm like, "Oh no." I'm like, they got him. They got him. They convinced him it was his problem.
That's pretty nice, but that's kind of crazy.
Yeah, they convinced him. He's about to drop $1,700 to play Flight Simulator. Like they won. So many companies and development agencies could be so lucky to the customer buys the game for $100 and doesn't work on his computer, so he goes, well, it's my fault.
Never happens, right?
Yeah.
Okay. Looks like we got a few people here, so I'll go ahead and get started. Hey everybody. So welcome to the AIASF Design Technology Meetup. As you probably know, today's discussion is going to be about modeling context in an urban setting. Before we get into that, I wanted to remind everybody that we meet every third Wednesday of the month from 5 to 6. At next month's meetup, we'll have a presentation from ArcVista and ArcSource talking about how to pick the best technology for your various workloads. So today we have two speakers here. We have Mike Hopp and Matt Walker. Mike Hopp is the creative director for Geopogo. He's worked at various architectural firms as an architectural designer and a 3D graphic specialist. He's used virtual and augmented reality for design presentation tools. He's going to talk about some of the things that he's been working on recently. Matt Walker is the 3D product manager at Aerometrics. He has a lot of experience providing 3D solutions for firms to help integrate their detailed models into their workflows, so to help them get detailed context around their models. So he's going to talk about some of his experience generating photogrammetric reality images for cities. So I think it's going to be pretty cool. So just as a reminder, this meeting is intended to be pretty formal. Feel free to ask questions as we go and speak up if there's anything you wanted to learn more about or ask about. So yeah, I think we're ready. So I'm going to start off by handing it off to Mike.
Oh, thank you so much. Okay. Well, I think the easiest thing is to share my screen and get started. So thank you everybody for coming. My presentation will be just kind of short, sweet, and simple. I'll give everyone an update on the work that Geopogo is doing, just in terms of our own ambitions with digital twins and cities and augmented reality. And then of course we have Matthew and Aerometrics, and they have created a phenomenal 3D model of San Francisco, which I think will wow and impress everybody here. And so they've done some scanning of the city, and so I'll pass it on fairly quickly, but I'll just kind of go through some a little bit of theory on where we're thinking we're all going with the power of these digital twins and these models, and what can we do with them from an architectural standpoint. And so let's jump into it. Okay, so yeah, everybody should see the screen here.
Yep.
Okay, perfect. So the Geopogo team has been starting to take a look at digital twins, and we recently got into some OSM data, which is OpenStreetMap data. We ended up pulling and ripping a bunch of it out from multiple cities around the world, and we started to take a look and ask the question, what happens when we gamify the OSM data and make it accessible to a greater public? Of course, we always want to serve the architectural industry, but it always starts to get very interesting when we involve the public into such capabilities, and we start to say, well, what's your vision of the city? What's your vision of this new development in this neighborhood? And because we work in game engines, we can simulate outcomes of development, and that is very important. And so we're in the very beginning stages of what we're creating, but I am going to introduce everyone to my hometown, which is of course Windsor and Detroit. And let's begin. So let's click start. And so I've already been in here a little bit, but here it is. This is Windsor and Detroit. And so Detroit, Michigan is on this side of the river, and this is Windsor, Ontario. And so this is my hometown. And for anybody who knows, I do work in San Francisco, so I'm always proud to show off my community. And so this is the OSM data that we ended up pulling and starting to compile. We've used our own terrain mesh. We started to put streets and all the different railroads, and we started getting some relevant buildings in downtown Detroit. Of course, Detroit has the Renaissance Center and a lot of different historic buildings that have kept the downtown alive. And of course, there's a whole bunch of new great developments that are happening from Bedrock Detroit. They're building new bridges across the Detroit River, the international border, and there's a lot of development. So we're starting to work with both cities, the city of Windsor and the city of Detroit. And we've posed the question to them, what is the future of our region with all this new development that's going to happen in the next 10 years? And more importantly, can we showcase the vision of our region? How do the downtowns work and interact with each other? How do the new bridges impact development in the future views of the cities? What happens when you start to go down into a neighborhood like downtown here and you start to play around and say, well, what if we turn derelict buildings into new sports centers, new sports arenas? What can that impact have on the community? And because we're using game engines, we're going to be able to simulate effects on development, get into some really fun detail for the public. So things like cars and people, walking around, ambient sounds. We can simulate traffic. We can simulate different data. And slowly we'll begin to update the model of the cities. And so right now we have just a massing mesh of the cities, but over time it's going to get textures. We're going to detail and populate relevant buildings. And then one day I would hope to work with Matthew and Aerometrics and do a whole scan of the entire region, have it in here, and then employ a lot of these editing capabilities into the city. And I think for people who know Geopogo, you can go to geopogo.com if you don't know us, but our whole ethos is how do we make architecture accessible to everybody? How do we make it engaging, fun, entertaining, and how do we create everybody into designers? Because we all have ideas, we just don't know how to express them. And so that's what we are here to do. So with that said, I'll keep this nice and simple. This is the platform here. You can go to designwindsor.com and you can actually download this for your PC and explore and play around with it. You can import BIM models into the model. And of course, some people may have seen the San Francisco model that we have of amassing as well, that we have on the Geopogo website. But with that said, this is Matt's show. So I'm gonna send the screen over to Matthew. Matthew has...
Before you do it, sorry, I have a question.
Yeah.
Well, first off, this is kind of funny. The things you talk about remind me a little bit of like SimCity, but so you mentioned because it's a game engine, you could kind of interact with it. Like this maybe seems like kind of a what would you call it, like a proof of concept or something. Like what kind of interactions or like analysis were you thinking of pulling it from? It sounded like maybe traffic stats. I guess you could do a traffic analysis and see if the new streets can hold higher levels of development or something. Like what kind of analysis are you thinking?
Yeah, so there's multiple layers. When you start getting into gamification, there's multiple layers that you can begin to employ. So the first thing, of course, is its all relevance and context. So this map is most powerful to the citizens of Windsor, the citizens of Detroit, and then of course the city officials, and then architects, builders, and developers. So first is context. It's always context. The second part is what can you start to do with the map? So people naturally, the first set of actions they engage in is exploration. They'll go explore the entire region and they'll go and find things like their home, or they'll go and find business or relevant views that they're aware of. The second part is editing. That is the second most important thing. And so an update we're about to release, you can edit and delete and modify and change all the buildings on the entire map. And so you can go in and delete houses, delete the Renaissance Center, whatever you want to do is your prerogative. The next part is changing, creating. So you can plant trees, you can place cars, you can import buildings from BIM, and we're creating a library of buildings that you can place over top. So parks, apartment buildings, office buildings. Then the final parts is shareability. And that's the most important part because everybody always wants to share their work. And so that becomes, could I send you a web link that you can join the session and see what I have created? Could cities start to do public presentations where they'll have a brand new center, like a new arena downtown? And could they invite the public to a public engagement? And they start to say, this is the impact and this is our great vision for our city as we go into the future. And so as we work with the two cities, these are natural behaviors that we're going to start to discover and employ.
Interesting. That sounds like a great idea for kind of community development, whether that's for new projects or like seeing what people in the community might want to add to their community. Interesting.
Yeah.
I think you mentioned you got this from OSM data, right? Is that like kind of looks like kind of Google Map data? Is that available for like most cities or most areas?
Most cities, you can rip the data. The caveat is, making use of the data. The reason we did OSM to start was because obviously we have control of the models and we can do whatever we want with them. Where when we tried to partner with other suppliers of data model, they kind of hold that very tight. And we needed freedom and flexibility to explore natural behaviors that our users were exhibiting. And so it's, every month we're updating and we're always seeing more and more.
I guess I just meant like theoretically you could probably do this for San Francisco or for some other city if you wanted to.
Oh yeah.
Data.
Yep. And here, I'll see if I can, Murphy's Law is never, it's dangerous to do live presentations. Let me, I'll just try here. It's dangerous though, so if my computer crashes, it is what it is. But
Sure.
let's see if it wants to play nice or if I can even, everyone's getting a quick little view of my methods of organization here. So
So it's a look behind the curtain, Mike.
Okay. Fingers crossed. Fingers crossed.
Sure.
Murphy's Law always wants to be mean. So I've done, most presentations we do, we always try and do live, kind of like you get what you get kind of thing. But there have been some where we just pre-record it because it's just too dangerous. You never know. Internet could go down. Computer could just say no. I had Windows Update one time. Windows 10. It just decided it was going to update, and that was that.
Man.
Yeah. But it's loading right now. You can see it spinning. So let's see what it does. But I don't want to take up too much more time because Matthew's got some really great stuff here.
Sure.
But it's a good segue.
The Geopogo platform would be great as well for that sort of community consultation. You could take it into a live event and use it to sculpt and sort of play around with the design or the environment as it were.
That's right. And so they have what's called a VR cave. The city of Windsor purchased a VR cave, which for those who are aware, there are these gigantic rooms with like 6 screens that you can walk into, and you wear these kind of glasses for depth perception. And that's what they want. They want to do large civic centered presentations using the $1 million device they purchased. And yeah, I don't know about $1 million, but
that's
okay.
Cool.
Yeah, so this is one map. It's still a little janky from just the way that we did some importing. but you can start to see here that we have the basic massing of the city. So you have Twin Peaks. We even threw in a little bit of Sutro Tower, Corona Heights. Dolores is over. Here's Dolores right here. I was showing Matthew Dolores. You guys will see it in Matthew's map. Dolores is just beautiful from his perspective because you get the whole scene of the city. And then you got all the different sections of the city. There's Civic Center. And then, of course, downtown with the Transamerica Pyramid, Salesforce Tower, Bank of America. And so what we want to eventually amalgamate is the beauty of Matthew's model into the ability to edit the city. And then, of course, have the entire region, so Berkeley, Oakland, all the way down to San Jose and Sausalito. So you want the whole region, you want the city, you want to edit the city, and you want to import your BIM. And then you'll see in Matthew's presentation some of the most beautiful renditions you'll witness. So I'm not going to take any more thunder. It's Matthew's turn to present.
One quick thing. We have a question here. Is the software free to access online? I believe you said you can access it.
Yes, yes. I'll put it in the chat.
Cool. Thank you. Okay.
Yeah.
Now you're on.
All right, Matthew.
Excellent. Thanks so much, Mike. And yeah, the great thing about, I guess, the data that you know, the photogrammetry data is, it is quite diverse, and it can be applied back to the data that you're showing there, Mike. It can be used to retexture and, you know, apply some of the richness back into other products. So that's a really exciting way to look at some of the use cases. But I might kick off and just introduce myself. So yeah, I'm Matthew Walker. I'm based here in Australia and work for a company called Aerometrics, and we make photogrammetric models. We fly 2 locations, and we charter aircraft, and we go around and do our flights and take lots of photographs, put them into some software, do some processing, and tie it all together and generate really rich 3D models as a result. And what I wanted to do before I sort of get into the models, I want to just talk a bit more broadly about photogrammetry and just give a bit of an introduction of, you know, how it's used, what the different types are, just to give a bit of an underlying information set. So I'll try to get through the death by PowerPoint quickly, and we'll get on to the fun stuff. So when we talk about photogrammetry, the products that we produce, there's a range of resolutions. Now, resolutions are just a way of saying the detail that's inside the model. We do a 5 centimeter resolution product for broad coverage, metro wide, a 2 centimeter product for higher detail and higher fidelity, and we do a street level enhanced product if we're wanting to do ground level viewing. Out of all these products, we can derive other data sets, LOD buildings, similar to what Mike was showing, point clouds, and true ortho imagery. I'll show examples of those as well. So starting with the 5 centimeter data, we've got the high resolution and high fidelity than a low res sort of 3D product, which is pretty common on the market at the moment. You get some economy of scale in the procurement of the data. It's a little bit more affordable. And when combined with a 2 centimeter data set across priority areas, and you put those 2 things together, you get really great detail in key locations, which is important, and you have other areas where you've got nice contextual coverage. We've got a number of off-the-shelf data sets in the United States already, in Denver, the San Francisco data set that we're just about to pop up, and we're coming soon. We've just completed the capture in Los Angeles, actually. So we're looking forward to seeing that. Our 2 centimeter resolution data set, it has 14 times more texture data than in the standard 7.5 resolution 3D data sets, which makes them really rich and vibrant in their use cases. We see them being used across a range of industries because it's such a rich and visual product, but it also is fundamentally reality capture. So what you're getting is a snapshot of reality at any given point in time. Our 2 centimeter models are also highly accurate. We use survey as ground control, and we tie the model all together so that the accuracy of the model is actually every point in the model that's well controlled is tied together to an absolute accuracy of 2 inches. So any point you can measure inside the model is good for that level of detail. We've got some those data sets that I mentioned, the same locations. We've got Denver, Miami, San Fran, and coming up Los Angeles. Although I'm not sure if we've done a 2 centimeter of LA yet. Just to answer the question in the chat, we don't have the LA model processed yet. We've just recently, in fact, in the last week, finished capturing it, and the next process after that is putting it through the processing steps to generate the model. So we'll likely see that come and get previewed in about a month's time. The next product that we have is the street level. And what this does is it actually combines our aerial acquisition with ground level content. And this makes a really exciting product that you don't see a lot of in the market, but it's actually something that works from the ground level. A lot of these photogrammetry models are shot from the air, so they're meant to be viewed from the air, typically 45 degrees down. But our street level enhanced data can actually be navigated on the ground level, and you can get really close to it, which makes it a really exciting product to work in for fly-throughs, to build for, you know, VR or other sort of more close experiences digitally. And it also gives you a really rich and exciting context to be able to use for communicating the actual existing environment. The derivative products that come out of the same captures of photogrammetry data. One is true ortho. So what I'm showing here is a typical aerial imagery capture. You can see that there's a slight perspective on some of the buildings, and particularly this one sort of in the center. And if we toggle to a true ortho, which is a derived product from the 3D mesh, you can see that there's no perspective anymore. We're actually rendering a top-down view of the photogrammetry mesh, and this gives you a perfect top-down view of everything. Nice, clean lines, no shadows inside the model, no perspective on any of the edges. So it makes it very easy to measure and understand exactly what footprint different products have. Point clouds are also able to be extracted from the photogrammetry mesh. And this is just a preference of workflow. Some people like to have point clouds that suits their software pipeline that they have. But the same mesh content, which is highly textured, can be converted into a colorized point cloud. And that sometimes works better for different packages and systems. And similarly, we can derive building models. So we start with the photogrammetry mesh, and we're able to use that as a basis to either automatically or with some manual intervention go through and actually convert these out to textured buildings. And these are, you know, a little bit more detailed than some of the content on the market at the moment, the OpenStreetMaps and some of the other vendors out there that are generating this content. There's a certain level of detail standard that's defined by the city GML standard, and we are able to supply compliant content that sits inside those different brackets. But there's nice, sharp and clean geometry, and this often suits some of the planning workflows a little bit better. Often the state likes to pick this up as a content set because it works a little bit more in some of the traditional GIS and planning packages that they have. So when do people bring in aerometrics? Well, we do captures where drones can't, either through proximity to people, freeways, rail alignments, or airports. All of these are no-go zones for drones and for typical acquisition methods. We also do city-scale captures. So we specialize in doing large areas and making sure that they're really consistent and accurate, and they all come out as a really nice quality model. We do large contiguous data sets, and we put a lot of effort into making sure our models are really, you know, looking great in terms of the color balancing and the detail that we resolve to. How do people engage us? Well, we sell models off the shelf, and we have a catalog of models which you can approach us to buy into and get a subscription or an off-the-shelf purchase for. But if you're looking to get a custom area that we don't already have, it's usually just a matter of sending us a shape and starting off a conversation. We quote based on the area and our mobilization costs, and that's a really straightforward process. In terms of the derived products, letting us know what formats you like to have, and any of the other requirements in terms of your projection or datum or the coordinate systems that you might need to use. All of those things can help us put together a good quote. There's a few other things in here, but I'm going to jump out of the slide deck now because I want to show off the real-time models. So We talked, and Mike mentioned that we've got a really great model of San Francisco. And we've got it in 2 resolutions, actually. We've got a 2 centimeter inner content set, which I'm only part way through loading in. So this is only about 1/3 of the content that we've got at the moment. Takes a little bit of time. I'm currently showing this in Unreal Engine. So this is running in the editor viewport. But this is our 2 centimeter data set, and this type of data is just captured at a slightly closer distance to the 5 centimeter data. And if you can sort of see the level of detail that we resolve to, you know, you're getting architectural detail is coming through there. Vehicles are really clearly visible. Vegetation resolves quite nicely. And the textures are really rich. So like if we go to the street art or the advertising that's, you know, present in locations, it all resolves really well. Crazily well sometimes. You know, you can spend a lot of time flying around these models, and I certainly do every time we get a new one. But let's talk about practical use cases, because the data is only as good as the use case that you put into it. You know, how can this data be used, particularly in architecture and proposal and development applications? Well, let's look at an example where maybe we want to bring in a proposed development. Maybe we have a development that we already have off the plan, and we want to look at what it looks like in situ. So here's an architectural model that I've grabbed from, I think, the SketchUp Warehouse library. It's, you know, it's about 10 or 15 stories high. It's quite humble in the context of the location that I've put it. But we want to understand a little bit more and communicate a little bit more with some of the stakeholders involved. Maybe it's the investors, or maybe it's the actual city of San Francisco. Let's look at what type of things we can do once we have this model put in place. Okay, well, first thing, we can look at the views of the immediate context. So I can go to any position inside the building, and if I have sufficient data loaded around me, I'm able to look at what those different view and line of sights are from one building perhaps to another building, and understand the proximity and the quality of the experience of being in that building. You obviously don't want to back a building directly onto another building and, you know, not have any light come in or have any of it be available for the sort of quality of the experience of living there. There's a great view out this side, so maybe that's the selling point for this particular vantage. We can go through all the floors and all the levels of the building, so we can even look at the street level experience through one of the lower floors and understand, you know, if I look down onto the street, what am I seeing? Construction at the moment, but that's okay. And because this is a dynamic model, you know, this is a real-time games engine, we're able to, you know, very quickly look at, okay, well, let's just play around and see what an orientation shift. What if we go 90 degrees and maybe we want to put in a second building that might be sitting adjacent to it. So it's very quick to iterate through these things and look at in situ, what impact do different decisions have. Being able to have these conversations early, we find is really powerful. You know, you could do this with some of the planning agencies. You can have conversations with the councillors, with actual state officials, and start to understand some of the constraints and the willingness for certain types of developments to go through. And what we find is by having all of the components of a rich contextual data model in there, you're able to address things a lot more quickly. So shadowing is one thing in Australia anyway that has a really big impact on certain dense areas. There's lots of constraints that we have here about overshadowing. So because we have a very accurate model, we know exactly where it's positioned inside the world. We've got it set up with the accurate time of day and the actual location. So we're able to look at the shadows that are cast at different times of the day and understand, you know, what impact do these two buildings have on the actual environment surrounding it. We can toggle those on and off and actually see, you know, the range of shadows at a range of different times of year as well. So we could jump into, at the moment, we're looking at the 28th of December. Let's come back to maybe June and have a look at the same shadows over you can see that this building actually falls in the shadow of another building quite significantly. Maybe that's a consideration for the site that we're actually proposing. And with enough data, we can absolutely, move around and put these buildings in different locations. Where I think the larger data sets become even more useful, and as I said, we've got the 2 centimeter data, which is very rich and very, very detailed for close-up interactions. We've also got the wider, let's see if my computer likes turning this on. Yeah, that's not too bad. The wider context in a 5 centimeter resolution data set. Okay, so this data is not as high fidelity. And maybe what I'll do is I'll just go over to that same bit of street art that we saw before. Let me see if I can find it again. And let's take a look at actually the difference in resolutions and the different use cases that we have. Here it is over here. Okay, so we're looking at, this is a 5 centimeter resolution product. So you can see maybe some of this fine writing on the left-hand side is not quite clear. But if we flick that off and jump to the 2 centimeter, okay, so we can start to read some of that writing a little bit more closely. And certainly when we look at the sort of fidelity of the models, that how it's resolving. And I'll caveat as well, these models are what we call un-QC'd. We haven't actually finished processing and refining these. We go through and fix up some of the major defects that come from the photogrammetry process. So you're kind of getting a bit of a preview look at what we typically release to the market. But there's certainly plenty of detail in there in both the 5 and, oh look, that must be a digital billboard because the content's changed on it between the 2 captures. That's funny. So yeah, different levels of detail, different resolutions, just allow you to be in different proximity to the content. Sometimes you want a macro view, which actually shows the development in situ. Sometimes you want something that's larger and allows you to look at it in a wider context. Once you get outside of the immediate content that we have available, there's other ways to supplement it further. So in this same scene, in the same real-time engine, I've got a world terrain layer that's been brought in, and it's developed and provided by Cesium, who are a sort of mapping and technology company. And they've integrated the plugin for Unreal Engine, which allows you to get the topography as well as some aerial photography and fill in the blanks. And that's a great way to just sort of make the whole model feel like it's situated, in the location. You can do longer views then and really get a sense for, how everything is fitting together. So we've got this idea of individual buildings in a city and in the context for development. If you take that to the next logical progression, there's the understanding that no one developer is developing at any given time in the city. There is a range of developments that's going on. There's a whole approvals process that the city is managing and going through. And I didn't quite crack it before we came into today's, but last night I had to play around with just going through and looking at some of the data, the open data that's available. And there's some layers there for approved developments. And they had a little bit of metadata and attributes about the heights of the buildings. What I've done is I've put those 2 together. I've sort of said that for this site, if we take the whole property boundary and we were to extrude it up to the height, it's obviously not realistic to what the development's going to be, but we start to get a feel for a handful of buildings at least, what type of new property is going to go in and what impact that might have on the proximity to any of the other buildings that we might be looking at. And if we paint this picture, across the whole city, what we start to get is a really great understanding of how our development and our proposal is fitting into the cityscape. What type of areas are getting approvals and some densification or a different sense of the community might be building up. And we're able to represent that in a more detailed way perhaps than it has been represented previously.
It's like the model just looks so cool to me. I mean, I realize that when you zoom in, you get, maybe not as much detail as you do when zoomed out, but it's a really nice overview of the context of of a place. And like I didn't know such such detailed models were like available to people. When I worked at SOM, internally we had sort of a model of the city of San Francisco. And I think generally for most of it, it was fairly kind of generic, maybe a little bit more like Mike's models. But like it's really cool to me just to have so much detail in the context for a project. I mean, as you mentioned, you could use that for a lot of different things. The developer could use it to help plan, to help like maybe price units to see what kind of views they have. You could use it during the planning process. I think some cities have requirements for like shadows of the building, wants to minimize the shadows that it casts in other buildings, or view corridors, I think are an issue in some places where you want to preserve the views of some other buildings, for example. And I don't know, I kind of agree with you. I just want to like look around the models a little bit myself and just like see what's in there.
And
cool.
There's great opportunity, I think, to put this in the hands of bigger projects where you're looking at public space and uplift of amenity. For instance, if this site here was turned into a public park, showing what different types of playgrounds could be put in, and consulting with the community about, okay, well, we plan to do this amount of planting. Maybe there's a row of trees that we want to put around the boundary with a playground in the middle and some fencing to keep it nice and safe for everybody. Maybe it's an off-leash park, or all these things can be communicated really well without any ambiguity, because it's all there. It's all laid out and really accessible in terms of the visual. And in terms of where we see this type of data being used, it really is across the whole spectrum of the planning and approvals cycle. So we see the data being used through strategic planning. A lot of time people will want to look at maybe a greenfields or a brownfields redevelopment. Maybe there's a whole precinct and a large industrial site that's going to be taken out and turned into a new mixed use type scenario. Showing that inside of this context and understanding how it's going to fit into the urban framework is a great way to leverage that content, even if it's just at a massing level. Let's bounce over to a little industrial area over here. I believe this is where the convention center, and it's certainly a bit of a technology park feel to it. But this is, again, the Unreal Engine is perhaps great for flying around data. It hasn't necessarily got the tools built into it for urban planning, but you can kind of bluff your way through it to some degree. If I can figure out why this isn't working. Oh, there we go. So just with primitives and, saying, okay, well, I'm going to have a 20 by 50 by 100 meter tall building. Cool. Hold on. Yep. And I want to put that there. Okay, I don't really like, oh, that's why. There we go, 20 by 30. And, let's just look at what that feels like in the context. Okay, it feels too high. Let's consider something that's a little bit more modest. 50 meters high feels about right. What does it look like if we've got 4 or 5 of those on the same area? Let's block that out quickly. And obviously, again, with the right tools. So there's lots of different packages that this type of data can go into. In terms of GIS, the Esri suite is really great. There's a platform and a software solution called Terra Explorer, which has got some really excellent modeling and GIS sort of tools that are available for bringing different types of data in together. And the only thing with this data is, it's all continuous mesh. So when I look at this data, and if I consider just one of these tiles of the data, it's a continuous surface. It's all one sort of set of geometry, and that means that if we wanted to remove this building from that geometry, we'd have to take that back to a 3D modeling package in this particular workflow. But some other packages like the Esri and the Terra Explorer suite, even Cesium to some extent in their web platform, allow you to actually draw a polygon around this and flatten the data down. So you don't have to go and do those really difficult manual edits that are a bit more in the 3D modeling workflows. But you can see here, just, within a couple of minutes, we maybe have a bit of a sense for, what type of height might be acceptable in this location. A good use perhaps in a further redevelopment of some of the parking space. And you can have a conversation very quickly and easily around that.
So you're viewing this in Unreal, right? Like, what format is the data actually in?
So these tiles that I've brought in here, I'm using the latest version of Unreal, which is currently in early release. And I'm using this one because it's able to deal with a phenomenal amount of geometry. Across this whole model, I believe there is over 300 million triangles in terms of data. And I've got all of that data loaded into this scene and this program. It adds up to about 100 gigs on hard drive.
Oh my goodness.
However, because we're really platform agnostic, we don't really push any particular platform. I'm using Unreal today because it's really performant and I can move around it quite easily. But we're able to push it out to, like I said, the Esri platforms, the Cesium web format, a lot of Bentley and MicroStation type platforms, have certain reality mesh formats, which can be used in a number of their different packages for infrastructure or digital twin type design. So the data can really get moved around between platforms quite a lot. In terms of architecture and sort of, some of the communication sort of stages, there are some programs that this data works really well in, just as the raw meshes, the FBX or the OBJ meshes, twin motion. We've got some videos on our website about how twin motion can be used with this data to great effect in fly-throughs to tell a story or to show what a proposal looks like in situ. Similarly, LumenRT and Lumion are two other packages on the market, which are really great. They've got excellent tool sets, good library of assets. You can add animations and really dramatic lighting in there. They're just not able to deal with as much content. So when you're doing them, you might be looking at, the context immediately surrounding your building. And in fact, that's actually a great way to get into using the reality mesh. If you're looking to pull it into your project and you're wanting to, start to have that engagement, the best way is usually to, look at what's directly surrounding you so that you can figure out and start to consider your design in situ. Buying the whole data set, can be prohibitive cost-wise for smaller developments. Certainly wouldn't be suitable for, if you were renovating your house or doing anything like that. This is sort of high quality data that is typically used for the larger scale. But when you've got these, multi-million dollar developments that are going in and they have a big impact on the environment, showing them in situ and giving a really good sort of visual to them. In fact, if I've got this data right and there is something of that height going in that location, you can imagine there's going to be a lot of important consultation.
No.
Not correct. Yeah, look, I did this very quickly, and I'll have to very much caveat that this is not representative in any way. But imagine if it was, and what communication you could have based on having that data in the model at that location.
Interesting. So it's been a while since I've looked at this, but I think most people probably here use Revit. And I believe you mentioned the FBX format, and I think I used to use FBX with Rhino. I think now that there are better ways to import Rhino files into Revit. But anyway, the point is, so it sounds like, could you maybe take like a 3x3 square block of the model and like export that to an FBX file and then like load that into a Revit model? Or would you recommend maybe exporting the Revit model to something else like Lumion? Maybe Lumion would give you better fidelity, but could you put it into Revit maybe?
Absolutely, yeah. You would use it throughout your process, so you might design against it. And what we've got launching as a way to purchase our data, certainly in the coming, I think 2 weeks, it should launch, is a 3D store. This one is built for Australian data sets, but the idea is you navigate to your area and you draw out a box just sort of showing the footprint of data that you're looking for. And then you get a cost for that data. On the left-hand side there, you can add it to your cart, put in some details, credit card details and your email address, and you'll be sent those FBX files as a download, and then you can bring them into your project, whether it's a Rhino 3D project or a 3ds Max or something like that. Revit is actually a tricky package. It doesn't like a lot of mesh. It uses procedural, geometry, and it sort of has moved away from, I guess, some of those sort of raw triangles, which is exactly what our data is based on. So there are ways to combine them together. Sometimes you need to push it back out to Navisworks as a way to sort of merge those two data sets together. Sometimes you push it out to programs like Twinmotion or Lumion or things like that. But certainly, using the data for different stages, initially for design, maybe for approvals and consultation, but taking it through to construction planning, it can be used for construction sequencing to great effect as well. We've got a little video here. So this is, this is actually a talk that Esri ran with a construction company here in Australia, and they built up a little tool set which is allows you to drop down a number of assets and put it against a platform, a program. So you can actually look at staging and what type of equipment is required when against the construction program. They're showing it in situ on an actual construction site from one of our data captures. Here's another data set that's for a bit of linear infrastructure, a pipeline upgrade that's going through. So it's really useful, again, to look at this in situ. Some of the considerations are, where is your on-street impacts going to be, and how long is it going to be there, and being able to talk to local stakeholders or the local authorities to manage that process and make sure that everybody's on board for it. Just gives everybody confidence and make sure that it's a smooth and streamlined process. I'm just trying to see, I thought I had another video, but I think I might have replaced it with that one. Oop. I'm just checking how we're going for time. I think we've got, a few minutes left. Look, there's just, I guess the other thing that, this type of data is very commonly used for is for fly-throughs, and this one. Using the same platform, using the Unreal sort of system. This is a quick fly through that I mocked up using just the 5 centimeter data, but it shows, that it reacts really well to that dynamic lighting. You can really craft a camera path in here that you wouldn't be able to accomplish with a helicopter or a drone or anything else. So you can really get creative with how you're telling your story or what sort of journey you're taking your customers through. And this is some of the fun of architecture, I think, and some of the fun of proposing something that's going to change the city, giving people a sense of emotion about it, and giving them a chance to really get inspired by the content that you're able to do. San Francisco is such a beautiful city already, showing how you can complement that and how exciting it is to have new development there, I think is a really, really cool thing to be able to do. And that's certainly where we get a lot of our sort of passion and drive from. We want our data to be rich and able to support those use cases, and really be ready and fit for use for a wide range of different sort of industries and platforms.
Yeah, the video is a little choppy. I don't think Zoom handles that super well, but like it's still crazy to me how much detail you got there. Like in how much detail that it's like very close to how the actual city is. It's crazy to me.
Oh, sorry. One other thing I was going to just quickly pop up. I mentioned street level detail before, and we captured the port building. Port Authority building at street level. So again, this is, you know, a different level of product, but the idea is that, you know, sometimes photogrammetry you want to be able to get even closer to and really get a sense for. This is un-QC'd again. This is not actually our final product. We would do a lot more cleanup on top of this before we put it out in the world. But this gives you a bit of an idea of how fine details can show up in this data and what it looks like from ground level, where you don't have some of the artifacts of the aerial acquisition. We go through and we tidy up, you know, things like these ghost people that come because they were there in some photos and not in others. But the really exciting thing is, you know, where this is captured in a way that we can do dynamic lighting on this. We can, you know, pop in really different use cases. You can imagine that this could be used maybe by the city to plan fireworks out in the bay and understand the backdrop, or maybe for a laser light show on top of the building itself. And even for, you know, event planning down on the ground level, where you can really understand exactly, you know, where are the bollards and what can we fit around those, and how people or equipment management work in this scenario. So there's really lots of different ways that you can use this data and different ways that it's fit for purpose. But certainly there's a range of products available and lots of different ways to bring it into and use with architecture. And that just really excites us and why we're working across, capturing these cities and bring them together.
You said that you could have what do you call it? Sorry, a point map too, right? A point cloud, excuse me, right?
Mm-hmm.
Have you guys done any like interior work either? Like seeing the Perry building, for example, makes me think of a use case where, like, you know, you get an image, or you get a map, I guess, of an existing building that you want to renovate, like a historic building, for example, and you'd have a really rich representation of the existing building to work with in your drawings.
We don't technically do a lot of interior spaces. There are other companies that do that, and laser scanning is a great way to approach it. You know, the little tripod mounted laser scanners are great at just being moved through the building. Even Matterport as a platform, if you've heard of that, has a really great product for, and they use a sort of hybrid photogrammetry point cloud and almost like Google Street View type 360 degree view product, which is really great for, you know, cataloging and documenting some of those interior spaces and stitching them all together. But we typically specialize in this sort of large scale outside, you know, citywide or project-based corridor. And that's where we've sort of planted our flag in terms of what we like to focus on.
Okay. Cool.
That's probably a good point there for me to pause and to see if there's any other questions.
Yeah, feel free, anybody, to speak up and pose your questions, or you could put them to the chat too. Either way, if you have anything you wanted to ask about. Like they like that we were doing a live demo. As you mentioned, like those are always kind of dangerous, but it's also really nice to see something actually working rather than pre-prepared.
That's right. Yeah, I think the model's just, you know, it's just unbelievable what you guys have created and captured. And I think with, you know, you put that in the right hands, you know, it's just amazing what can be done with that. So.
And I think that it's interesting, you know, the Australian market has had access to this data for a little bit longer. You know, I used to consume this data before I moved over and started working for Aerometrics. I worked in a visualization and a 3D company, and you know, I was probably dealing with this type of data for some of my projects maybe 6 years ago. And you know, I think it's really only becoming mainstream and available for the US market in the last year or two. And I think that there's always that sort of stage of, you know, how do we use it? When do we bring it in? What's the right point? But once the cities or the states start, you know, adopting it, it becomes a lot more synonymous. And sometimes, you know, they get picked up. There's open data sets that get released. We've certainly got some demo data sets out there, but there's lots of different ways that they can be brought in. And we're just excited to see more and more of this 3D cities, being represented. I think it leads to better outcomes in planning. It leads to better communication across the whole spectrum of the planning process. Yeah, we just fundamentally think it's the way that everything is moving. It just helps communicate and give clarity.
And I saw the other day, it looked like they were going to do a full 3D scan of the entire southern tip of Australia.
Yeah.
And it's just unbelievable. Like,
That's
as we move
ambitious.
into the future, I think you're going to see, I think cities are going to take greater authority over a lot of their planning initiatives. Like, of course they do now, but we're going to be confronted with a lot of challenges as we move into the future, especially when you look at climate change and you look at California. This is real. This stuff is happening in real time. We all know it. That state, we're in trouble. And if we think we're going to make it in 10 years and it's going to be the same, that's, I think we'll be very fortunate if that's the case. And cities need to better plan themselves. We have to stop urban sprawl, and we need to use these maps to effectively simulate the entire outcomes of the future. And that's the power that we have right in front of us. And if it's going to take some talented people to put their minds together to do that, that's just what it's going to be.
Yeah, flooding information is, readily available now, and you start to combine, some of that geospatial data or the other simulated data with these sort of, geopositioned and accurate data sets. You can paint some really vivid pictures, some terrifying if in their starkness, but it's important to tell these messages. It's important to understand, what does our future look like if we stay on particular trajectories, and how do we plan for that? Because some paths we're on, we're perhaps too far down. So understanding, how do we keep people safe, and how do we deal with the worst case scenarios in some of these events? It's definitely empowering, I guess, good decision making, and that's another sort of positive, I guess, of that type of use. It does let people make better decisions in that context.
Yeah. So on that note, seems like we don't have any more questions. So I'd like to thank Mike and Matt for being here and presenting to us, and thank everybody for attending. So it was a good talk. Thanks, everybody.
Thanks for having us. Thanks, Mike.
Thank you guys so much.
Thanks, Dennis.
Thank you, Matthew. Thank you, Dennis.
Thanks, everyone.